Hello friends, welcome to my channel We Do For You. In this video, you will learn about prime numbers, composite numbers, HCF, LCM, prime factors, co-prime numbers, how to calculate HCF, how to calculate LCM. Let's start. First, let us learn about what is meant by multiple. When a particular number x multiplied by another whole number, the result is called multiple of the number x. Of course, it is a multiple of y also. Say I have taken number x. When this is multiplied by the another number y, whatever the result you obtain, this result is called multiple of x. Of course, it is a multiple of y also. When x is multiplied by another number z, the result is called the multiple of x, also multiple of z. For example, let's take a number 6. When 6 is multiplied by number 1, the result is 6. So 6 is called multiple of 6. When 6 is multiplied by 2, the result is 12. So 12 is a multiple of 6. When 6 is multiplied by 3, you will get 18. 18 also a multiple of 6. Of course, 18 is a multiple of 3, 12 is a multiple of 2, 6 is multiple of 1 also. Let's understand what is a factor or a divisor. Factor is a number that you can use to divide a particular number x evenly. Then y is called factor for x. If y can divide x evenly means remainder equal to 0, then y is called factor of x, or x has factor y. Here the condition should be it should divide evenly. If the number y divides x evenly, that is with remainder 0, then y is called the factor of x. Let us take some examples. I am taking number 12. So when I divide 12 with 1, the remainder will be 0. So I can say that 1 will divide 12 evenly. So 1 is a factor of 12. Say let us take 2. When 12 is divided by 2, the remainder is 0. So I can say that 12 is evenly divided by 2. So 2 also a factor for 12. Let us take 3. 12 divided by 3, the remainder is 0. So 3 also a factor for 12. Next 4. 4 is also a factor for 12 because it is dividing 12 evenly. Next 5. When I take 5, 5 to 10, the remainder is 2. As remainder is 2, it is not divided evenly. So 5 is not a factor. 6, yes, it is a factor. 7, no. 8, no. 9, no. 10, no. So 12. When 12 is divided by 12, so the result will be 1. So remainder is 0. So 12 also factor. So now what are the factors we have seen for 12? 1, 2, 3, 4, 6, 12. So these all are the factors for 12. 1, 2, 3, 4, 6, 12. From this, what did we learn? For any number, 1 and the number itself will be always factors. Let's take 18. So 1 and 18 will be always factors for 18. Let us take number 7. So 7 will be having a factors 1 and 7. So the number 1 and the number itself will be always factors for that number. Now let us learn what is a prime number. Prime number. If a number is not having a factors other than 1 and itself is called prime number. So if the number x has only factors 1 and x only, then the number x is called prime number. It means it don't have any factors between 1 and x. If we are not able to find any factor between 1 to x, then the number x is called prime number. Now let us see how to find a given number is a prime number or not. Finding a number is a prime or not. If the given number n has no other factors other than 1 and n, then the number is called prime number. So what we have to do? We have to find out if there are any factors between 1 to n. If you found one factor also, then we can say that that number n is not a prime number. If you don't find any factors between 1 to n, then we will say that n is a prime number. Let us take one example, 144. Let us try to find whether it has factors or not in between 1 to 144. 144 can be divided by 2 evenly. So 144 is not a prime number. But let us continue to find factors for 144. So just now we found 2 is a factor. So when 2 multiplied by 72, the result will be 144. It means 144 can be divided by 2 and 72 also. So finding one factor will lead another factor automatically. 144 can be written as 3 into 48 also. Means 144 has the factor 3 and 48. So 144 can be divided by 4 evenly. 4 into 36. So 4 and 36 also factors for 144. Next 6 and 24 also. Next 8 and 18. Next 12 into 12. So these are the factors 2, 3, 4, 6, 8, 12, 18, 24, 36, 48, 72. See, while finding the factors, we no need to find from 2 to n minus 1. For this 144 till where we have found, for this 144 till where we have tried till 12. After that, the factors will be repeated. So provided a number n, we have to try till the square root of n. So 2 to square root of n. Convert this square root of n into the integer, then whatever the value you obtain, till that number you can try. If you are not able to find any factor between 2 to square root of n, then you can say that that number is a prime number. We can say that if we are not able to find a factor of a number up to the value of its square root, we will not be able to find any factor above the square root, and the number under consideration will be a prime number. So for example, let us take 147. So 147 is above 144 and below 169. So what will be the square root of 147? It will be 12 point something. So if I convert this into integer, so this will be 12. So if I am not able to find any factor between 2 to 12, then 147 is a prime number. Let us check whether 147 is a prime number or not. 147 is not divisible by 2. Let us check whether 147 is divisible by 3 or not. 1 plus 4 plus 7, that is equal to 12. Divisibility rules that we have already learned. 12 is divisible by 3. So 147 also divisible by 3. So 147 is not a prime number. Let us take another example. 149. Whether 149 is divisible by 2? No. Divisible by 3? No. Divisible by 4? Last two numbers are not divisible by 4. No. 5? No. As 2 and 3 is not divisible, 6 also it will not be divisible. 7. 14 minus 18 minus 4. No. 8. No. 9. As it is not divisible by 3, we no need to check with 9. 10 also? No. 11. 9 plus 1, 10, 10 minus 4, no. 12 also no. So as this number is not divisible by any number between 2 to 12, so we can say that 149 is a prime number. Let us reduce this to further. If the number is divisible by 8, what does it mean? It will be divisible by 2. If the number is divisible by 8, it will be divisible by 4, isn't it? So if the number is divisible by 6, it will be divisible by 2. If the number is divisible by 6, it will be divisible by 3, correct? If the number is divisible by 10, automatically it will be divisible by 5. So, what I'm trying to say, between the numbers 2 to square root of n, we no need to check each and every number. We can check only with the prime numbers. So, if I have to check whether 149 is a prime number or not, I have to check whether that number is divisible by 2, 3, 5, 7, 11. Because these are the prime numbers which are present below 12. For example, let us take 173. Whether 173 is a prime number or not, we have to check. So till where 173 lies between 169, 196. So square root of 173 lies between 13 to 14. So 13 point some x. So if I round off it, the number will come as 13. So I have to ensure that there is no factor between 2 to 13. So what are the numbers I have to try with? I have to try with only these numbers. So 173 is not divisible by 2. It is not divisible by 3. It is not divisible by 5. 7. I have to check with 7. 17 minus 6. 11. It is not divisible by 7 also. 11. It is not divisible by 11 also. 13. It is not divisible by 13 also. So I can say that 173 is a prime number. So what are all the prime numbers present below 100? You should always remember this. 2, 3, 5, 7, 11, 13, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 93, 97. We missed 17 here. All these 25 numbers, try to remember. Now I will tell you a small trick to find a number is a prime number or not if the number is less than 169. Okay. So try to remember these numbers. 77, which is a multiple of 7 and 11. 143, 11 and 13. So 91, 7 and 13. 119, 7 and 17. 133, 7 and 19. 161, 7 and 23. If you remember these numbers, 77, 91, 119, 133, 143, 161 are not prime numbers, then remaining any number you take, just check whether it is divisible by 3 or not. If it is divisible by 3, then it is not a prime number. If it is not divisible by 3, it is a prime number. Don't try this with even numbers because all even numbers will be divided by 2. So you have to try with only odd numbers. 2 is only even number which is a prime number. Remaining all prime numbers are odd numbers only. So in between 1 to 169, if you want to check any odd number is a prime number or not, you just check with whether that number is divisible by 3 or not. If it is not divisible by 3, you simply say that it is prime number. For example, let us take 127. Whether it is divisible by 3? No. 1 plus 2 plus 7, that is 10. So 10 is not divisible by 3. So it is not divisible by 3. So 127 is a prime number. Let us take another number, 137. 137 is divisible by 3? No. So 137 is a prime number. Let us take 147. 147 is divisible by 3? Yes, it is not a prime number. Let us take 153. It is divisible by 3. 1 plus 5 plus 3 is equal to 9. 9 is divisible by 3. So 153 is non-prime number. Let us take 83. Whether 83 is a prime number or not, 8 plus 3, 11. 11 is not divisible by 3. So 83 is a prime number. Now we have learnt prime numbers. Now let us learn composite number. Prime number is nothing but if you have only factors 1 and itself, then it is a prime number, right? Composite number is quite opposite. If you have any one factor between 1 and itself, then the number is called composite number. So all non-prime numbers will be called as composite numbers. So what is meant by composite number? So a composite number will be having a factors. So can we say that we can write any number into multiplication of prime numbers? Writing a number into multiplication of prime numbers is nothing but prime factorization. Let us see how it is. For example, I have taken 12. 12 can be written as 2 multiplied by 6. Again, whether 6 is a prime number or not, it's not a prime number. So 6 can be written as 2 into 3. So 12 can be written as 2 into 3. If you see here, all are prime numbers. 2, 2, 3. So writing a number into multiplication of prime numbers, this is nothing but prime factorization, or we say that standard form. Let us take another example, 20. 20 can be written as 2 into 10. 10 can be written as 2 into 5. This is the prime factorization of 20. If you take any number, let's take 42. 42 can be written as 2 into 21. The 21 can be written as 3 into 7. So 42 can be written as 2 into 3 into 7. So we can write any number into multiplication of prime numbers. This is nothing but prime factorization. Writing a number into prime factors is very, very important. Based on this, you will face n number of problems in number system. Now let us learn what is meant by HCF or GCD. HCF stands for highest common factor. GCD stands for greatest common divisor. Say you have given two numbers and asked you to find the HCF of those two numbers. How to find the HCF of these two numbers? Let's see. Find the factors for each number. Identify the factors which are common to both the numbers. Of these factors, whatever the highest factor you found, that will be the HCF. For example, 12, 18. So what are the factors for 12? 1, 2, 3, 6, 12. 1, 2, 3, 4, 6, 12. For 18, 1, 2, 3, 6, 9, 18. In these two, what are all the common things? 1, 2, 3, 6. So which is the highest? 6. 6 is called HCF of 12 and 18. So first what we have to do? So write down the factors for each number. Identify the factors which are common to each other. The highest factor or the greatest divisor is nothing but HCF or GCD. If the given numbers are big numbers, how to do that? So write down all the numbers into multiples of powers of prime numbers. Then write down all the common prime numbers with their lowest power. Multiply the above numbers, we will get the HCF. Let's understand this with examples. First example, this we have already seen. Let us find HCF for 24 and 36. So 24 can be written as 2 into 12. 12 can be written as 2 into 6. 6 can be written as 2 into 3. Okay. So this can be written as 2 cube into 3. Now 36. 36 can be written as 2 into 18. 18 can be written as 2 into 9. 9 can be written as 3 into 3. So it is 2 square into 3 square. Writing the number in multiples of powers of prime numbers. Okay, now what we have to do? We have to write down all the common prime numbers and its lowest power. Here it is 2 square and for 3 it is 3 power 1. So 2 square means 4 into 3. 12 will be the HCF of 24 and 36. Let's solve for 84 and 126. 84. How we can write 84? 84 can be written as 2 into 42. 42 can be written as 2 into 21. 21 can be written as 3 into 7. Okay, that is 2 square 3 into 7. Now 126. 126 can be written as 2 into 63. 63 can be written as 3 into 21. 21 can be written as 3 into 7. This is 2 into 3 square into 7. So what are the common prime numbers are there? 2, 3, 7. Lowest powers are 1, 1, 1. So HCF will be 2, 3, 6, 6, 7, 42. So 42 will be the HCF. Okay, let us take one more example. 231, 561. Okay, let us solve this in different way. Okay, so 231, 561. How we'll do? So let's divide 561 with 231. Okay, so 231 2's 462. So if you subtract 462 from 561, you will get 99. So now with this 99, we have to divide 231. Okay, 99 2's, that is 198. So if you what will get? You will get 33 as remainder. Now with this 33, try to divide 99. So 99. 33 3's 99. So as we got the remainder 0, this will become the HCF. Okay. The other way how we can do? 231 can be written as 3 into 77. 77 can be written as 3 into 7 into 11. Okay. Similarly, 561 can be written as 3 into 11 into 17. We have to write down common prime numbers with their lowest power. So 33 will be the HCF. Now we'll try to find out HCF for these two numbers, 1440, 3240. 1440. So 1440 can be written as 2 into 720. 720 can be written as 2 into 360. 360 can be written as 2 into 180. 180 can be written as 2 into 90. 90 can be written as 2 into 45. 45 can be written as 5 into 9. 9 can be written as 3 into 3. Okay. So this is 2 power 5 into 5 into 3 square. 3240. 3240 can be written as 2 into 1620. 1620 can be written as 2 into 810. 810 can be written as 2 into 405. 405 can be written as 3 into 135. So 135 can be written as 3 into 45. 45 can be written as 3 into 15. 15 can be written as 3 into 5. So 2 power 4. So this can be written as 2 cube into 3 power 4 into 5 power 1. So in both we have 2, 3, 5 are common. What is the lowest power? 2 cube, 3 square and 5. So 2 cube is 8, 3 square is 9, 5. 8 5 is 40. We have to multiply each one of them. So 2 cube is 8, 3 square is 9, 5. 8 5 is 40, 49 is 360. 360 will be the HCF. Okay. The other way how we can do? 3240. We have to divide this with 1440 with 2's. So it will become 2880. What will be the remainder? 0 3 360. Now if you divide 1440 with 360, so 366 1440, so you got the remainder as 0, so 360 will be the HCF. This is how we calculate HCF. Write down the number into multiplications of powers of prime numbers, write down the common prime numbers, have the lowest power on them, multiply them, you will get the HCF. Okay. Now let us learn about co-prime numbers. If for any two numbers there is no common factors other than 1, then that two numbers are called co-prime numbers. When two numbers HCF is 1, it means that those numbers don't have any common factors other than 1. Okay. Two consecutive natural numbers are always co-prime numbers, be it 7, 8 are co-prime numbers, 61, 62 co-prime numbers, 756, 757 co-prime numbers. Two consecutive odd numbers are always co-prime, 5, 7, 21, 23, 750, 717. These all are co-prime numbers. Of course, two prime numbers is always co-prime numbers. And one prime number, next number which is not multiple of that prime number will be co-prime number. Let us take 7. Any number other than 7 multiples like 15, 22, 23, 24. These all are co-prime to 7. 715 are co-prime. 722 are co-prime. 723 are co-prime. 724 are co-prime numbers. Okay, if you take 11, 11 into 23, 21, 24, 25, 26, 27. These all are co-prime numbers to 11. Okay. If we have to say 3 or more numbers to be co-prime numbers, then each pair of that number should be co-prime. Let us take this example, 17, 19, 21, 22. If I have to say all these are co-prime, then each pair of them must be co-prime. If you take 17, 19, it's a co-prime number. Then 17, 21, it's a co-prime numbers. 17, 22, they're co-prime. Similarly, 19, 21, co-prime. 19, 22, co-prime. 21, 22 also co-prime numbers. Why we are learning these co-prime numbers? We will learn the utility of these co-prime numbers in the next section, that is LCM. Rules for spotting three co-prime numbers. Always three prime numbers are co-prime to each other. Three consecutive odd numbers are always co-prime. Say 7, 9, 11. One more. Three consecutive natural numbers such that the first number is odd. 23, 24, 25, 11, 12, 13, 71, 72, 73, 41, 42, 43, 55, 56, 57. Now let us learn how to find LCM. What is the full form of LCM? Least common multiple. Say you have two numbers. Okay, so first write down the all multiples for each number. Identify the first common multiple, that will be your LCM. Let us take one example, 12, 18. So 12 multiples are 12, 24, 36, 48 and so on. 18 multiples, 18, 36, 54. So here 36 is common to each other and this is the least one. So here you will get 72 next, here you will get to next 72. But this is not LCM. Least one is least common multiple. Which multiple which is common to both numbers and which comes first is called LCM. LCM is 36. If the numbers are big, how to calculate? Write down each number into multiples of powers of prime factors, that is prime factorization. We have learnt in the HCF section. Write down all prime numbers and their highest power. In HCF, we will write common prime numbers and their lowest power. In LCM, we write all prime numbers with their highest power. Multiply all of them, then you will get the LCM. Let us understand with few examples. Let us find LCM of 24 and 64. 24 can be written as 2 into 2 into 2 into 3, that is 2 cube into 3 power 1. 64 can be written as 2 power 6. Now what are all the prime numbers present? 2 and 3. What is their highest power? Here 6, here 1. 2 power 6 is 64 into 3, that is equal to 192. 192 will be the LCM for 24 and 64. Now let us find LCM for 54 and 36. 54 can be written as 2 into 3 cube. 36 can be written as 2 square into 3 square. So now writing down all prime numbers with their highest power. Here 2 square, here is 3 cube. 2 square is 4, 3 cube is 27. 27 fours 108. 108 will be the LCM for 54 and 36. Now let us find the LCM for 36, 42, 72 in two ways. In the first way, 36 can be written as, we already seen this, 2 square into 3 square. So 42 can be written as 2 into 3 into 7. 72 can be written as 2 cube into 3 square. So LCM will be, so 2, which is 2's highest power 3, 3's highest power 2, 7's highest power 1. 2 cube is 8, 3 square is 9 into 7. 8, 9, 72. 72 into 7. 504 will be the LCM. Let us see now how we can get the answer in another way. So we'll write down 36, 42, 72 here. Now we will try to find the LCM for 36, 42, 72. So 2 18s, 2 21s, 2 36. Okay, now all these three numbers will be divided with 3. 3 6s, 3 7s, 3 12s. Now again this will go with 3. 3 2s, 7 will come as is 4. Now we'll be dividing with 2. 2 1s, 7 will be as is 2 2s. Now we have got all our prime numbers. So multiply each of them. 2 into 3 6, 6 3s 18, 18 2s 36, 36 2s 72, 72 7s, that is 504. In this way also we will find the LCM. While finding LCM, if you encounter this kind of scenario where 7 is not divisible by 3, we will write it down as is. The condition is at least two numbers should be divisible by this prime number. Eventually all the final result here, it should be co-prime numbers. Now let us learn few tricks to calculate the LCM. If the numbers are co-prime, just multiply them to get the LCM. What are the co-prime numbers? If the two consecutive natural numbers are co-prime. So what is the LCM of 5, 6? It is 30. What is LCM of 12 and 13? That is 156. What is the LCM of 9 and 10? That is 90. Okay, next. While calculating LCM for many numbers, if you observe co-prime numbers, just multiply them and write down the result. Look for the what part of the other numbers covered in this result. Write down if there is any uncovered part. Let us understand this with one example. Let me take 9, 10, 12, 15. Let us find LCM for these four numbers. Now 9 and 10 are co-prime numbers. So we'll write down 90. In this 12, what portion is covered here? 12 can be written as 2 into 3. 1 2, 1 3 is already covered. 3 is covered in this. 2 is covered in this 10. So the leftover part is 2. So we'll write 2 here. In this 15, both 3 and 5 are covered in 9 and 10. So 90 into 2 will be the LCM. Here I have written very important LCM. One should remember to solve the problems quickly. Okay, let us go through them quickly. 2 3 4 LCM is 12. 2 3 4 5 60. 4 and 6 24. 4 6 8 24. 8 12 24. LCM for 10 12 or 10 12 15, that is 60. LCM for 18 24, that is 72. LCM for 12 16 48. LCM for 14 and 16 112. 14 and 18 126. 16 and 18 144. 12 16 18 144. 30 40 120. 40 60 120. 30 40 60 120. These are very few important LCMs. You must remember them to solve the problems quickly. Whatever we have learned in this chapter, LCM, HCF are very important. The utilities of this The usage of this will be there in all the chapters of the aptitude and reasoning. This finding LCM and HCF will help you a lot in solving the problems. Choose random numbers and try to find the LCM for them. Similarly for HCF also. The problems on LCM and HCF we will see in the next videos. Again I am telling, this is very important concept. You must practice this. If you have learned something from this video, please like the video. If this video is useful for some others or your friends, please share with them. If you have any doubts, please comment them. Please give me your feedback also. Thank you for watching this. Thank you very much. Please do subscribe.